Hello dear students, welcome back to e-classes of P.N.AMERSEY High School Standard 12 Commerce subject Statistics. Today we are going to start with the fourth chapter, that is limit. Let's understand certain terms which we will be using in this chapter. This is your part 2 textbook, chapter number 4, that is limit. Define an interval. Now, how we will define an interval? Interval means a set of real numbers, and those numbers can be between any two real numbers. For example, if we take the numbers between 1 to 10, then this will be one kind of interval. So, interval means a set of real numbers between any two real numbers, and this is called an interval. Now, if you take any real number, it can be negative, positive, or 0. The modulus of a real number is always non-negative. Non-negative means positive. For example, if you take modulus of -1, it will be +1. Modulus of +1 will also be equal to 1. That means if we have to take the modulus of any real number, it will be 1. So this is the first definition which we should know, that is interval. Second is, what is the meaning of modulus? The intervals can be classified into four types. The first one is closed interval. If we take a set of real numbers a and b, and the numbers which we are including in this set are a, b, and the numbers between them, then it is called closed interval. That is, if a and b are real numbers, then the set of all real numbers between a and b, including the two numbers, that is a and b, is called a closed interval. Closed interval is denoted by the symbol box bracket AB. Let us understand the second definition, that is open interval. The set of real numbers again between the two values a and b, but a and b are not included, they are excluded in this open interval, and therefore we can define it as the set of all real numbers between a and b excluding a and b, that is a and b are not involved, not included, is called open interval. And the symbol for open interval is AB. In both the cases, A is less than B. So in the first one, since A and B are included, it is written as A less than equal to X less than equal to B. And in the second case, it is written as A less than X less than B. Next is closed open interval. Now what is the meaning of closed open interval? In this interval AB, A will be included but B will not be included. So again it is an interval of real numbers which includes A but not B. And the symbol for closed open interval is AB. The box bracket will be towards A and open bracket will be towards B. The next is open closed interval. Open closed interval means A is not included but B is included. So the set of real numbers between A and B, including A but excluding not including A but including B, is called open closed interval, and it is denoted by open bracket you will show towards A and closed bracket you will show towards B. Now suppose this is a real line, axis you can say. If this is the value x equal to 0, so the nearby region of x equal to 0, that is from -1 to 1 or -0.5 to +0.5, that region is called as neighborhood of A. That means any open interval which is containing A is called neighborhood of A. So we can say neighborhood of 0 is what? -1 to +1. That means that value A should be between the two extreme values. We can define delta neighborhood of A, where A is a real number, delta is non-negative real number, and this A minus delta to A plus delta is called delta neighborhood of A. That means we can say over here, suppose if this is A, this is the two extreme values. So this will be A plus delta value and this will be A minus delta value. So the interval from A minus delta to A plus delta will be known as neighborhood of A, where delta means this distance, that is from the two extreme points to A, that distance is delta. Neighborhood of delta is denoted by NA delta, which can be also written in the form of modulus, that is x minus A is less than delta. So delta neighborhood of A we can express in three forms: neighborhood form, modulus form and interval form. Neighborhood form we can write it down as NA delta. Modulus form we can write down as x minus A modulus less than delta, or you can say mod x minus A is less than delta. Interval form we can write down as A minus delta to A plus delta. Now this neighborhood form means, I told you that if this is the value x equal to A, then the region around x equal to A is called the neighborhood. So we will solve the sums based on this, that is we will be finding neighborhood form, modulus form and interval form. Let's solve first question of your exercise 4.1. Now let's solve this. Express the following in modulus and interval form, and these four sums are given: 0.4 neighborhood of 4, 0.02 neighborhood of 2, 0.05 neighborhood of 0 and 0.001 neighborhood of -1. Let's solve it. First, if you see 0.4 neighborhood of A, if I compare this with delta neighborhood of A, we will get A is equal to 4 and delta is equal to 0.4. Now you know modulus form is mod of x minus A is less than delta. Let's substitute the value of A and delta. So we will have x minus A is 4. So we will have x minus 4 less than delta. What is delta? 0.4. So mod of x minus 4 is less than 0.4 is the modulus form. Let us find interval form. Interval form is A minus delta, A plus delta. A is 4, delta is 0.4. So let us substitute over here. We will have 4 minus 0.4 to 4 plus 0.4. 4 minus 0.4 is 3.6 and 4 plus 0.4 is 4.4. Let's solve the second one. 0.02 neighborhood of 2. In this also, as I have done in the previous one, what is A? 2. And what is delta? 0.02. Now the modulus form is mod of x minus A is less than delta. Let's substitute A is equal to 2 and delta equal to 0.02. So we will have mod of x minus 2 less than 0.02. Now let's find interval form. Interval form is A minus delta, A plus delta. Let's substitute A is equal to 2, delta equal to 0.02. So we will have 2 minus 0.2, 2 plus 0.2. 2 minus 0.2 is 1.98 and 2 plus 0.02 is 2.02. So the interval form is 1.98 to 2.02. Let's solve the third part. 0.05 neighborhood of 0. So here A is 0, delta is 0.05. So for finding modulus form, let's substitute A equal to 0, delta equal to 0.05. So we will have mod of x minus 0, and x minus 0 is mod x, that is less than delta, and delta is 0.05. So value will be mod x is less than 0.05. Let's find interval form. Interval form is A minus delta to A plus delta. A is 0, delta is 0.05. So let's substitute it. We will have 0 minus 0.05 and 0 plus 0.05. 0 minus 0.05 will be minus 0.05 and 0 plus 0.05 will be 0.05. Let's solve question number 4. 0.001 neighborhood of minus 1. So here A is minus 1 and delta is 0.001. So let's substitute A equal to minus 1 and delta equal to 0.001 in the form mod of x minus A less than delta. So when we substitute over here the modulus form, we will get it as x minus minus 1, that is x plus 1, less than 0.001. What is the interval form? A minus delta, A plus delta. So let's substitute. We will have minus 1 minus 0.001, and the next one we will have minus 1 plus 0.001. So our answer will be minus 1.001 to minus 0.999. Let's solve question number 2. Express the following interval and neighborhood form. Let's see the first one. First is mod of x minus 2 is less than 0.01. Similarly, we'll do the three parts of it. Let's solve the first one. Now in mod of x minus 2 less than 0.01, if we compare with the formula modulus form, that is x minus a is less than delta, we will get a is equal to 2 and delta is equal to 0.01. Now what is interval form? A minus delta, A plus delta. Let's substitute it. So we will have 2 minus 0.01 and 2 plus 0.01. So the answer will be 1.99 to 2.01. What is the neighborhood form? N A delta. So let's substitute. A is 2, delta is 0.01. So our answer will be N 2.01. Let's solve the second part. Modulus of x plus 5 is less than 0.1. Now if we compare with x minus a mod is less than delta, what you will have? A is equal to minus 5 and delta is equal to 0.1. Let's substitute in the form A minus delta to A plus delta. What we are having? A is equal to minus 5, delta is equal to 0.1. So when you substitute over here, we will have minus 5 minus 0.01 to minus 5 plus 0.1. Minus 5 minus 0.1 will be minus 5.1 and minus 5 plus 0.1 will be minus 4.9. Neighborhood form is simple, that is N A delta. Let's substitute. A is minus 5, delta is 0.1. So our answer will be N minus 5, 0.1. Let's solve the third question. Modulus of x is less than 1 by 3. Comparing with x minus a less than delta, what is a over here? 0. Delta is 1 by 3. Now you know interval form is a minus delta, a plus delta. So let's substitute 0 minus 1 by 3 to 0 plus 1 by 3. 0 minus 1 by 3 is minus 1 by 3. 0 plus 1 by 3 is plus 1 by 3. So our interval will be minus 1 by 3 to plus 1 by 3. Now what is neighborhood form? n a delta. Now here a is 0, delta is 1 by 3. So our answer will be n 0 1 by 3. Let's solve the fourth part. Modulus of x plus 3 is less than 0.15. Now let's compare with modulus of x minus a is less than delta. Here if you see a is minus 3, delta is 0.15. Let's substitute in the interval form a minus delta, a plus delta. A is minus 3, delta is 0.5. So what we will get? Minus 3 minus 0.15, and the other extreme value will be minus 3 plus 0.15. So our answer will be minus 3.15 to minus 2.85. Now let's find the neighborhood form, that is n a delta. A is minus 3, delta is 0.15. So our answer will be minus 3, 0.15. This is the neighborhood form. We have done the sums based on this from the exercise 4.1. Solve it. This question is sure to come for 2 marks in the exam. In the next session, we'll continue with the same exercise. Thank you.